Okay, so we talked about chemical reactions. We know that in a reaction on the left side we have what? What are they called? On the left side? No, on the left side of a reaction, we call them the, Cody?
Coefficient.
Reactants. Thank you, reactants. And on the right side, we have products. We read this middle symbol as yields. The mass in a reaction is equal on both sides of a reaction because mass is conserved, and because of that we know that the number of atoms is equal. This is a review. We know that the number of atoms, each type of atom, has to be equal on both sides of a reaction in order for our mass to be correct. So, there are some steps we've been following to writing a balanced equation. And so a balanced equation, we call that whole thing, the reactant, yield, product, we call that whole thing a chemical equation. Okay? So when we do that, the first step, and this should be a review because we've already done it, but this you can write down so you forget, you can come back to it. The first step is to write the correct formulas. Correct being the key word. For all reactants and products. So in order to write the correct formulas, we need to know how to balance oxidation numbers or charges, just like we've been doing. So that involves a lot of knowing VC gain. Okay? That involves a lot of knowing VC gain. Do I need to get my classroom management tool?
What is that?
It is the water squeezy bottle. If you fall asleep for a second, we'll have to get it out and spray you for a second. But if you fall asleep for a whole period, we might have to pour the whole thing on top of you. So everyone knows you're sleeping.
Over and over and over.
So I would pay attention. I've gone to 4 years of college to learn how to use this classroom management tool, so I'm quite a pro at it. Pay attention.
This is the first time hearing this water bottle.
It's the first I've heard anyone sleeping in my class.
Really?
Yeah? Okay, so we need to balance the oxidation numbers. So we really need to pay attention to the VC gain and make sure that you have the proper balance of atoms in your formula, okay? Of elements in your formula. The second step is to remember the diatomics.
What's that? Just kidding.
Funny you should ask.
I have that right here.
Diatomics are those atoms that always occur as pairs.
Yeah, I knew that.
Those elements that always occur as pairs. And there was one that I left out in your list yesterday, and that was hydrogen. So there's hydrogen, oxygen, nitrogen, and then all of the halogens, which is fluorine, bromine, iodine, and chlorine. So all of those are going to occur as 2s. For example, H2. It will never just occur as H. Those are diatomics. And finally, and most importantly, you are going to balance the equation and how do you do that, you may ask? You're going to add coefficients spelling this right? Coefficients? Yeah. In front of the formulas.
Blank N2 plus blank H2.
Okay. Do not add them in the middle. We can only add it in the front, and it sort of acts as distributive property in math. So, for example, if you had 2 CO2, that sort of acts like a distributive property. So that means we have 2 carbons and how many oxygens?
4.
4 oxygens. Those coefficients distribute to everything in the formula. What about if we had the formula copper 2 hydroxide, and we had 2 of those? We would have how many coppers?
2.
Okay. How many oxygens?
4.
Okay. So we have 2 times 2, so 4 oxygens. And how many hydrogens?
4.
4.
Okay. Good. So you have to use this first and then distribute again. Okay. This is your other big one, is never change the subscripts. That will change the formula, and we can't change the formula. We have to use what was given. For example, Christopher, do you guys know Christopher Haluska?
Yeah.
Okay, he told me a joke this morning, chemistry joke. He said, a guy walked into a bar and said, give me some H2O. Another guy walked in and said, give me some H2O. And the third person walked in and said, I would like some H2O too. Okay, what's H2O to?
That acid, that stuff.
It's not an acid.
Not good.
This one has its own special name. H2O2?
Hydroxide.
Close. Peroxide. Hydrogen peroxide. Okay? You guys have used hydrogen peroxide. That's what we used in the elephant toothpaste. Is that something you want to drink? Is that different than H2O? So we can't change the subscripts because then it means we are drinking hydrogen peroxide. We're working with something different than what we were given. So you can't go about changing those. You can only change the coefficients. Okay?
What about? Why did chicken cross the playground?
Get to the other slide.
Yeah,
I read your joke. So, let's do examples because that's the best way to learn this. Okay? So, if I were to give you the word equation,
What?
the word equation
What?
of zinc plus hydrogen chloride yields zinc chloride plus hydrogen What's our first step?
Right. Zinc.
Okay, write out our correctly balanced formulas. So zinc would be
Zi.
not Zi,
Zn.
Zn. And what state of matter do you suspect zinc would be? Solid. Okay. Plus hydrogen chloride.
HCl.
Okay. Which, that's actually not a great way of saying that. But it would be HCl. Actually, what's another way of saying HCl, since it's an acid?
Hydrochloric acid.
It'd be better if we called it hydrochloric acid. Okay. Now, acids, when we use acids, we usually denote them as being aqueous. Okay. Yield, so what do we need to draw?
A yield sign.
The arrow. Okay. And we end up with zinc chloride. So what's the charge of zinc?
Plus.
Plus 2. So how would we do the formula for zinc?
2.
Chloride is
Cl.
Cl2, correct. Okay, and this is going to be aqueous. Plus, you'll find out.
Hydrogen.
Plus hydrogen, and what do we know about hydrogen?
Plus. Plus.
H2, because it's a diatomic. And H2, hydrogen, is what state of matter? Gas. So we're going to expect bubbles when we do this reaction. Basically what we're saying is we're adding some acid on top of zinc metal, and we would expect to see some bubbles, and then what's left behind is going to be zinc chloride. Okay, so now we need to, we've got our proper formulas, now we need to do a little math and see how many of each of these we have. We have how many zinc?
1.
Okay, how many hydrogens?
2. 1.
How many chlorines? Okay, and on this side we have how many zinc?
1.
How many chlorines? Or how many hydrogens, I should say first? 2. And how many chlorines?
2.
Okay. So we're not balanced, so what do we need to do?
Fix it.
Where could we, what subscript, or sorry, not subscript, what coefficient could we add? Yes.
2 plus side.
A 2 where?
To the left.
To the left in front of what?
The
HCl. Now how many hydrogens do we have?
2.
And chlorines? And are we good? Okay, good. Get the idea? Those are the steps you go through. This one was a lot easier than some of them may be. Some of them may take some practice and some, you probably won't get all of these on your first try. Okay, here's another example. This one might be a little more challenging for you, okay? If I give you, and try writing this on your paper. Before I even get it, try writing these formulas, okay? Aluminum sulfate plus calcium hydroxide yields aluminum hydroxide and calcium sulfate. Try and write that